Good evening, everybody. I hope you had a wonderful day until now. From now, I'm going to go through different laws, at least 3 laws. And these 3 laws, will be talking about pressure, volume, number of mole, and temperature. Okay. So I will be talking about 4 factors. And here are the factors. First one will be pressure. Pressure always has to be in atmosphere. Next, volume. Volume needs to be in liter. Number of mole, okay, it will be in mole unit, and temperature must be in Kelvin. I'm gonna change. I'm gonna keep 2 of these factors, 2 of them constant, and I will follow the relationship between the rest. Okay. For example, for the first one, we will keep N and T constant, not equal, constant, and we want to know the relationship between pressure and volume. Okay. What's the relationship between the pressure and volume? Okay. Is it, indirect, direct connection? We need to assign it. So it's going to be, is it directly connected or inversely? Next one, you go N and P constant. So you're talking about connection between temperature and, again, volume. We want to know whether it's direct or indirect. And the third one, you go, this time you keep temperature and pressure constant. And you want to know the relationship between N and volume. Okay. The first one, pressure will be connected to the volume, but indirectly. So the correct answer will be this one. Next one, temperature directly connected to the volume. That means the correct answer will be here, B. And the third one, number of mole directly connected to volume, or volume connected to the number of mole. If you increase N, volume will go up. Okay. So that's going to be the correct answer. Okay, here we go. First one we call it the Boyle's law. Boyle's law, it says if you keep number of mole and temperature constant, whenever you increase the pressure, volume will be smaller. Okay. When you increase the volume and when you increase the pressure, volume will be smaller. So okay, as you see, this is P1 and that one is P2. Here we have V2 and that one is V1. P1 is smaller than P2, but V1 is bigger than V2. So pressure inversely connected volume, or volume inversely connected to pressure. If you increase the pressure, volume will be a smaller number. Okay. Okay. If you want to make this one equal, you want to change this one. Give me a second. You want to turn it to equal sign. Just multiply both sides by a constant number, and you get V equal to K over P. So you get PV equal to K. If you change P, then volume will be 1. It will be V1, and that one is K. If you change it to 2, you multiply it by second volume, and still it will be K. Right sides are equal to K. Right side are equal to K. Then the left side needs to be equal. So that means P1 V1 is going to be equal to K, and is equal to P2 V2. So this is going to be your formula, and we call it here P1 V1 is equal to P2 V2. This formula, it will be solid to some extent. If you increase the pressure to a high number, the gap between molecules, it will be smaller, and that's the time that you will have interaction between particles. Right now, we are talking about theoretical gases or ideal gases. What's the meaning of ideal gases? Gases that you do not have interaction between their molecules. Do we have such a gas or gases? No, we don't have ideal gases. Any gas you pick, it will have interaction between its molecule. Okay, there will be interaction between the molecules. And whenever you increase the pressure, that interaction gets stronger. That's the reason, when you take a propane cylinder and you shake it, you hear liquid, because the pressure is so high that it made the molecules to get closer to each other and start to have interaction between them, and they turn to liquid. Okay, we have an example here. It says initial volume is 946 milliliter, and then initial pressure is 726 milliliter of mercury. They're saying if the final volume is 154 milliliter, tell me what's the final pressure. Okay, so we go with this. We go P1 equal to 726 milliliter of mercury. P2, we don't know it. B1, it says, was B1 946 milliliter, and B2 was equal to 154 milliliter. Okay. We are looking for P2, so we go P1 B1 equal to P2 B2. That means P2 will be equal to P1 V1 over V2. So here we go. P2 equal to P1, 726 milliliter of mercury, multiply V1, which is 946 milliliter, divided by 154 milliliter across milliliter by milliliter, and it will give you the final answer equal to 4.46 multiply 10 to the third milliliter of mercury. Okay. Now we have three cyclic here, three cyclic. Okay. If you want to know the final pressure in atmosphere, if they did not ask for it, but if you want to transfer it, you take the final answer and divide it by 760. This one, it will give you 5.87 atmosphere. They did not ask for this part. Okay, so let me end here. Say this one, this piece was not part of the question. We added. Or just simply let me underline here. Okay, one point before I go to the next question. I said the pressure always supposed to be in atmosphere, volume in liter. So how come I did not transfer any unit here? There is no need to do it. Mathematically, you are just going to make, headache for yourself, or you're doing extra work, for no reason, to be honest. Because milliliter, it will be canceled by milliliter. Whether you write it in liter or milliliter, they will cancel each other. So what's the point of, writing volume in liter when they cancel each other? Okay. Pressure, I use milliliter of mercury, and whatever I use, it will show up at the end. If they ask me to find it in atmosphere, I could just simply transfer this one to atmosphere, and whatever I get at the end, it will be in atmosphere. Okay. Next question, which is the charge law. Charge law says keep number of mole and pressure constant. So keep number of mole and pressure constant. Okay. And it says keep, here's the second law, keep N and P constant. We know if temperature goes up, pressure will go up. But they are telling you, keep it constant. Don't change the pressure. In order to keep the pressure constant, you have to expand the volume. You have to increase the volume. V must go up. Why volume must go up? Because pressure inversely connected to the volume. And if volume goes up, pressure will go down. So every time we hit the object, pressure will go up. In order to keep the pressure constant, we need to let the volume to go up. So temperature, it will go up. Result, higher pressure. Okay, in order to keep the pressure, so I'm going to say try to keep pressure constant. In order to do it, V or volume must go up. Okay, volume must go up because based on the first law, volume indirectly connected to pressure, pressure indirectly connected to the volume. If volume goes up, pressure will go down. It will go down until we reach the initial pressure. And that's the reason we say the pressure now still is same number. So we say we did the process under constant pressure. Okay. And based on Charles' law, if the temperature goes up, temperature in Kelvin goes up, volume must go up to keep the pressure constant. Okay. So by increasing temperature, volume, it will go up. T2 and this one, T1. T2 is bigger than T1. And as you see, V2 is bigger than V1. That's not surprising. This one we call it Charles' law. And Charles' law, the formula for it is equal to V1 over T1 equal to V2 over T2. Key point here, temperature must be in Kelvin. It must be in Kelvin. What's the unit for volume? It can be anything. It can be milliliter or liter. It doesn't matter really because they will cancel each other. But the temperature must be in Kelvin. In Kelvin. Okay, before I do one example, theoretically, if T is equal to 0, then volume will be equal to 0. But we cannot really get the 0 Kelvin. Why? Because it's close to 0 Kelvin. Still, we have something that we call a degree of freedom. That means there is tiny movement. If there is movement, that means there is energy. And if energy is not 0, then temperature will not be 0. Okay? If energy is not 0, temperature will not be equal to 0. Okay? Here, it doesn't matter really how much mass you are dealing with, whether the pressure is 1 atmosphere or, I don't know, whether you're dealing with 1 mole or half mole or 0.25 mole. If you cool that gas and you reach 0 Kelvin, theoretically, volume supposed to be 0. Okay, all those gases, all those number of moles, they will reach each other in one point, and that's going to be equal to the absolute 0 or 0 Kelvin. Okay, whether you have 1/2 or 0.25 mole, all those three graphs, they will meet each other in one point, and that's going to be equal to T0 when the volume is equal to 0. Remember, volume is this line. Okay, and if we hit the horizontal line, that means volume here B is equal to 0. But in reality, we cannot make it to 0 Kelvin. That means volume always will be bigger than 0. Okay, there's an example here. It says initial temperature is 22 degrees Celsius. Initial volume is equal to 2.54 liter. We keep the pressure constant, 1 atmosphere. Now tell me what's going to be the final volume when the final temperature is minus 197 degrees Celsius. So you have both temperatures. You have initial volume. You're looking for final volume. Okay, look to the temperatures. Temperature on degrees Celsius, you need to have them in Kelvin. So I'm going to go after the temperature. I need to use this formula, V1 over T1 equal to V2 over T2. Let's get the right unit. T1 is equal to 22 degrees Celsius. T2 is equal to minus 197 degrees Celsius. I need to have them in Kelvin. So I'm going to add 273 to both of them. First one will be 295.15 Kelvin, and the second one 76.15 Kelvin. Okay. And volume is given. V1 is equal to 2.54 liter, and V2 equal to, here we're looking for it, so it's missing. Now go after V2. V2 it will be equal to V1 multiply T2 divided by T1. So you go 2.54 liter multiply 76.15 Kelvin divided by 295.15 Kelvin, and the final answer is equal to 0.655 liter. Next law, it will be the Avogadro law. Third one, remember, I said we have three options. I showed you the options here. First one was the Boyle's law, pressure directly connected to volume, or volume directly connected to pressure. We kept N and T constant. Second one, we kept N and P constant. Volume directly connected to temperature, and that's the Charles law. So first one, Boyle's law, second Charles law, and the third one will be Avogadro law. We're dealing with number of mole. We say volume directly connected to number of mole when T and P are constant. When T and P are constant, equal number of moles of different gases will occupy same volumes. Again, equal number of moles of different gases will occupy same volume under same temperature and pressure. Okay, so if you keep T and P constant for different samples of gases, equal number of moles from those gases will have same volume. Okay. By increasing N, volume will be bigger. That's not surprising. If you have more students, you need to go to a bigger room to accommodate, the students, or hold that class. Okay, so this is N1, that is N2, here V1, and that one is V2. N1 smaller than N2, so expect V1 to be smaller than V2. Okay. The formula is V1 over N1 equal to V2 over N2. Okay. Here's the example. We start with 0.158 mole from a sample of gas. We added 0.113 mole to it. We have the initial volume. Initial volume is 2.64 liter for 0.158 mole of that gas. Now, if you add something to it, we'll expect the volume to be bigger. You go with this. You go V1 over N1 equal to V2 over N2. You have N1 equal to 0.158 mole, and V1 equal to 2.46 liter. N2, because they said additional, if we go back to the question, because it says if additional 0.113 mole, we are adding to the initial number of mole. So you say new number of mole is going to be equal to N1 plus 0.113. Okay. So you get 0.158 plus 0.113 moles. and it will be 0.271 mole. Okay, so let's go after V2. V2, it will be equal to V1 multiply N2 divided by N1. We have 2.46 liter multiply 0.271 mole. You divide it by 0.158 mole. You cross mole by mole. The final answer is 4.22 liter. Okay, we finished the third law. Okay, so now we should be able to come with a general formula. And the general formula will be this: volume directly connected to pressure, volume directly connected to temperature, volume directly connected to number of mole. If I merge these three formulas, let's call this one 1, 2, 3, connect all of them or merge them, we get this: V indirectly connected to number of mole multiply temperature divided by pressure. Let's make it equal sign. So we get V equal to constant number, okay, constant number, whatever, I'm going to call it K, multiply NT divided by pressure. Okay, I'm going to replace K by R, okay, replace K by R, and I get this: V equal to R multiply NT divided by pressure. I will rearrange this formula. It will give me PV equal to N R T. Okay. What's the R? R is a gas constant and is equal to PV divided by NT. Okay, P, it will come with atmosphere, volume with liter, and N with mole, and temperature Kelvin. And that's the right unit for R. And R is equal to 0.08206 atmosphere to liter over mole to Kelvin. We call R gas constant. Okay, gas constant. So from now we will be dealing with PV equal to nRT, ideal gas formula. Okay, let's do some example about it. Here's the formula and R, and I wrote the unit for each one. Okay, we start with temperature equal to 0 degrees Celsius, pressure 1 atmosphere. We have one number, we have 1 mole. Let's find the volume. Okay, let's find the volume, but I'm going to do this. I'm going to say pressure equal to 1 atmosphere. I added digits after the decimal point. Okay, and I mentioned this one during the class because I just want to have more, more sig-fig. It's not going to change the story at all. Okay, so please add digit to the decimal after the decimal point. Temperature, let's go with 0 degrees Celsius. It's going to be 273.15 Kelvin. Number of mole equal to 1 mole. Now let's get the volume for this data. Volume, it will be equal to nRT divided by pressure. N is 1 mole. R, you go with gas constant. Divided by 1 atmosphere. We get the volume equal to 22.4. And the unit, if you cross mole by mole, Kelvin by here, Kelvin, atmosphere by atmosphere, we are left with liter. Okay, just liter for the volume, which is the right unit for it. But how did we get this volume? We had 1 mole from a gas. So this is volume for 1 mole gas. Okay, in order to show, to say this volume is volume of 1 mole gas, we say 22.4 liter per mole. Per mole. So I divided by mole to show that this is volume of 1 mole gas. So we say this: 1 mole gas has volume equal to 22.4 liter under STP condition. What's the STP condition? Standard temperature and pressure. So STP is the standard temperature and pressure. Temperature must be 273.15 Kelvin. And pressure 1 atmosphere. Under STP condition, volume of any gas, it will be 22.4 liter per mole. So this is volume of any gas. Okay, any gas, and that was the reason that I did not mention what's the here. I did not mention any name of the gas after the mole unit. I just simply said 1 mole. 1 mole of what? Yes, the question says 1 mole oxygen, I believe. Look to the question here, it says 1 mole oxygen, but I just simply said 1 mole. Okay, because I wanted to tell you, regardless of the nature of the gas that you are using, volume will be always 22.4 liter per mole under STP condition.